Good afternoon, students. In last class, we have discussed regarding the thermodynamics basics. In that, second law of thermodynamics and spontaneous processes, criteria for the spontaneity we have discussed in the last class. So today we will discuss regarding thermochemistry, the basics of thermochemistry, and then bond energy or bond enthalpy, and then bond energy calculation or change in enthalpy of the reaction. So what is thermochemistry? In previous class we discussed regarding the thermochemistry. Thermochemistry is the branch of chemistry which deals with energy changes in chemical reactions is called thermochemistry. The energy change that occurs in a chemical reaction is largely due to the change of bond energy, that is, change of potential energy that results from the bond breaking or the formation of bonds in a reaction. Now, what is thermochemistry? We know that thermochemistry is the branch of chemistry which deals with the change of energy in a chemical reaction. So, basically we have studied two types of reactions in thermochemistry, exothermic reactions and endothermic reactions. As already we discussed in the previous class, exothermic means where heat will be evolved and endothermic means heat will be absorbed. And the next basic term that we are discussing in the thermochemistry branch is enthalpy of formation. Already we know that what is enthalpy. Enthalpy is the amount of energy, the total amount of energy present in a system is called the enthalpy. Enthalpy is represented by H. And then what is enthalpy of formation? The enthalpy of formation of a substance is defined as the heat change that takes place when 1 mole of the substance is formed. Its elements, when 1 mole of substance is formed from its elements under the given conditions of temperature and pressure, that is considered as the enthalpy of formation, and it is usually represented by delta Hf. H, you know that enthalpy, delta represents change in enthalpy of formation. So, the enthalpy of formation of a substance is defined as the heat change that takes place when 1 mole of the substance is formed from its elements under the given conditions of temperature and pressure is called the enthalpy of formation. Now, what is standard enthalpy of formation? Standard enthalpy of formation is defined as the heat change accompanying the formation of 1 mole of the substance in the standard state from its elements, also taken in the standard state. The elements are also in the standard state when 1 mole of the substance is formed. When 1 mole of the substance is formed from its standard elements where the standard elements are also in the standard states, that enthalpy change occurs, that is called the standard enthalpy of formation. For example, we will take reaction of carbon with oxygen. Solid carbon, when undergoes combustion with the help of atmospheric oxygen, what happens? The carbon dioxide gas will be evolved or liberated. The change in enthalpy of that reaction is minus 393.5 kilojoule. So how you are explaining this reaction? When 1 mole of carbon dioxide is formed from its elements carbon in solid state and oxygen in gaseous state, all substances being taken in the standard state. The substance carbon and oxygen is taken in the standard state and 393.5 kilojoule of heat is produced. Hence, the standard enthalpy of formation of gaseous carbon dioxide is 393.5 kilojoule. So what is the standard enthalpy of formation? When 1 mole of the substance is formed in the standard state from its elements also taken in the standard state, whatever the enthalpy change occurs, that is called the standard enthalpy of formation. Bond enthalpy or bond energy. The bond energy of a particular bond is defined as the average amount of energy released when 1 mole of bonds are formed from isolated gaseous atoms, or the amount of energy required when 1 mole of bonds are broken so as to get the separated gaseous atoms is called the bond enthalpy or bond energy. Bond energy is also called sometimes the enthalpy of formation of the bond. So, some of the bond energies are listed. The bond energy of hydrogen-hydrogen bond is 435.1 kilojoule per mole, and hydrogen-bromine bond energy is 368.2 kilojoule per mole, and HCl bond energy is 430.9 kilojoule per mole, and HF bond energy is 564.8 kilojoule per mole, and oxygen bond energy is 138.1 kilojoule per mole. These are the standard values listed. So, on the basis of these values, we have to calculate the change in the enthalpy of the given reactions. So, in the problems, they may ask, calculate the change in enthalpy of the reaction, whether the reaction is exothermic or endothermic. So, how we have to calculate means, we have to take the bond energies of the reactant and the product, and then we have to calculate the change in enthalpy of the reaction. So let us solve one of the problem. Calculate the enthalpy change for the reaction hydrogen gaseous state plus bromine gaseous state to gives 2 HBr, 2 moles of hydrogen bromide gaseous state. The given that the bond energies of hydrogen is 436 kilojoule per mole, and bromine bond energy is 190 kilojoule per mole, and HBr hydrogen bromine bond energy is 364 kilojoule per mole respectively. In the problem only they have gave the bond energies of the hydrogen bromine bond and hydrogen bromine bond. We have to calculate now the enthalpy change for the reaction. Now the solution: by calculating the total energy absorbed and released, we come to know that what is the change in enthalpy of the given reaction. So energy absorbed in the dissociation of H bonds, hydrogen bonds, is equal to 435 kilojoule per mole, and energy released in the formation of 2 moles of Br bonds is 192 kilojoule per mole, and total energy absorbed is equal to 435 plus 192 is equal to 627 kilojoule per mole. And then energy released in the formation of 1 mole of HBr bonds is equal to 368.2 kilojoule per mole. Therefore energy released in the formation of 2 moles of HBr bonds is equal to 2 into 368.2, that is equal to 736.4 kilojoule. So the energy released is greater than the energy absorbed. As we observed the values from the calculation, energy released is greater than the energy absorbed. Hence the net result is the release of energy. Energy released is equal to 736.4 minus 627, that is equal to 109.4 kilojoule per mole. Next problem we will go. Calculate the change in enthalpy for the following reaction. H2 plus Cl2 gives rise to 2 moles of HCl. The solution: from the data you know that the H bond energy is 435.1 kilojoule per mole, and chlorine bond energy is 242.7 kilojoule per mole. So we have to calculate H and H plus Cl and Cl bond energies. So what is the value? 435.1 plus 242.7 gives rise to 2 moles of HCl are there. So the HCl bond energy is 431. We have to multiply with 2 because 2 moles of HCl is formed. 2 into 431. So in next step what we have to do? 677.8 minus 862. What will be the enthalpy change? The enthalpy change is negative, that is 184.2 kilojoule per mole. Therefore the change in enthalpy is negative. The reaction is exothermic. So next problem, students. 2H2 plus O2 gives rise to 2 moles of water molecule. So already we know that the bond energy for hydrogen, the bond energy for the hydrogen bond is 435.1. because 2 hydrogen bonds are there. We have to multiply 2 into 435.1 plus the oxygen, the double bond is there, diatomic molecule. So the oxygen double bond energy is 493.7, and OH bond energy is 464. HOH bond energy is 464. So 4 moles of OH bonds are there because 2H2O means 4 OH bonds are there. So 4 into 464. So change in enthalpy delta H is equal to, so we have to multiply 2 into 435.1 plus 493.7, that is 1363, minus 4 into 464, that is 1856, is equal to minus 492.1 kilojoule per mole. If the change in enthalpy delta H is negative, means the reaction is exothermic. Heat is evolved, the reaction is exothermic. In this way we have to calculate the change in enthalpy of the reaction by considering the bond energies of the bonds present in the reactants and the products. So we have to calculate the change in enthalpy from the given data given in the problems. Thank you, students.